Hi guys. So I'm gonna change a little bit because we were working with basic figures like triangle and rectangle. Today I'm gonna do something a little bit more funkier than the ones that I did before. It's a really nice problem, a really nice shape. And I'm gonna point out some of the problems that the students have when I have asked these type of problems in my exams. So I hope that if you're my student and you are watching, don't stand up in the exam and ask me that question because I'm gonna make fun of you. If you are not my student, then you know me. So if you are not my student, please take the clue. Don't ask your professor about that. So let's see what is gonna happen. This is gonna be the shape that I'm gonna be solving. So we have this shape. This is my y-axis here. This is my x-axis here. This is a solid shape because I'm doing moment of inertia of areas, remember that. And I know that this distance here is 100 millimeters. And I know the equation of that, and the equation of that is y equal 1/50 times x squared. So this is what happens here. I'm gonna start solving the problem, and I know that at some moment of the problem I'm gonna need this height. It's gonna be needed. You can be sure of that. And then you are taking an exam and you've realized that you don't have that distance. And what happened is that you have a lot of information, a lot of bits of information, but you are still not connecting those bits of information. And that's what you have to do. Even though you don't have written here the distance, you have the distance. It's here. You have the equation. So if you have the equation, you can calculate that distance or that height. So easy, right? Then why don't you think about that in the exam and you stand and ask me, y equal 1/50 x squared. What is x? Well, if I want to calculate it here, that should be x, right? I'm calculating the height when this curve moves up to that point. What is that? So y equal 1/50 multiplied by 100 squared, which means that y equal 200 millimeters. There you go, 200 millimeters. So this height here is 200, or I'm gonna copy it here, yeah, 200 millimeters. I don't have to give it to you, I already did. I gave it to you. Now I haven't even told you what I haven't even tell you what the problem is asking you to do. But the problem is asking me to do moment of inertia with respect to x, and we might just for fun do moment of inertia with respect to y also. Every step, everything, first step that you have to do is copy your equation. What is your equation? Integral of y squared dA. Now that means that I'm going to measure y, and my differential of area is gonna be this one, from here to here. So once again, I have to find this distance from here to here because this is dy, because this is y. Problem, finding dA. That's the same famous problem in every time that you solve these type of problems. That was a redundancy, by the way. But here is easy. You see, this is a curve. The distance from my axis to here, that's x. And the distance from my axis to here is also x. That means that this distance from here to here is 2x. Problem solved. 2x. Oh, I don't have x. Yes, you do have x. Your x is here. So you get this equation and you solve for x. And when you solve for x, you have x squared equal 50y. So that means that x equals the square root of 50y. And I'm going to put this just in terms that are easier to do the integration. So I'm going to say that x is equal to square root of 50 multiplied by y to the 1/2, which is the same thing. I'm going to keep this like that. Now my whole band width is 2x. So my differential of area is going to be 2x times dy. But x is equal to this. So my differential of area is going to be 2 times square root of 50 times y to the 1/2. That's my differential of area. Plug this differential of area into that equation, solve it, and problem is done. So then we're gonna do that. Ix equal the integral of y squared multiplied by that y to the 1/2 dy. I'm sorry, I missed the y here. I know it happened. I also make errors from time to time. So this is there, dy. This is constant. I can take this out of the integral. So Ix equal to square root of 50 integral. This is y squared. Square is actually saying 4/2, 4/2 plus 1/2. Keep the base at the exponents. 2 plus 1/2 is 5/2. So then you have y to the 5/2 dy, and between what limits and what limits? Between what limits and what limits? Well, remember what we do. We get the differential of area and we sweep the whole area from here to here in the direction that I'm measuring y, from here to here, and that's from 0 to 200. That's why we needed that. And the students get stuck in that point and they don't have the problem right because they can't think that they just have to put that into the formula, the x into the formula, and calculate the y. So 0 to 200. Remember, this is going to be millimeters. I'm not going to put the units until the end. So Ix equal to square root of 50 multiplied by y to the 5/2 plus 1 divided by the same thing. So y plus 5/2 plus 2/2 is 7/2 divided by 2/7, which is the 7/2, which is the same thing as multiplied by 2/7, and that's evaluated between 0 and 200 millimeters. And when you do that, then I sub x is going to be equal, where is my calculator? Calculator, here you are, calculator. 2 times square root of 50, I do 50 to the 0.5, times y, which is y is 200 elevated to the 7/2, which I could say 3.5, multiplied by 2 divided by 7, and that is equal to 457,142 857.1 millimeters. Millimeters what? What are the units for moment of inertia? I'm waiting. Yes, millimeters to the 4th. Those are the units for moment of inertia. If you want to express this in scientific notation, you can say that Ix equal 457 times 10 to the 6 millimeters to the 4th, and that will be all for this problem. Now in the next video I'm gonna do the same problem, but I'm gonna solve it and I'm gonna find the moment of inertia in the other direction. Now what if, and just what if, question for you, I'm not gonna solve it, but what if you have to do this problem with respect to the centroid? Think about that. Well, the first thing that you have to do is find the centroid, and you have an equation for find the centroid. Remember, y bar times total area equal this integral of y dA. So you solve for that, and then you locate the centroid. And once you locate the centroid, you can apply parallel axis theorem from here to there. That's gonna be a lot easier than locating your axis at the centroid. See you in the next video, guys. I have a meeting. I have to go. Have a nice day.